Hey everybody, it's Mr. Mott. What we're going to do is look at this lab activity called comparing amounts in a recipe. And what we're going to do is going to mix different amounts of baking soda and citric acid. When they mix, they're going to produce a gas. And what we're going to do is look at the ratio or the proportions of baking soda to citric acid and see which one produces the most gas. So what I've done already is that I put 10 milliliters of water in here using a graduated cylinder. And then I put some baking soda in here as well. We're going to be mixing this up once we add the citric acid. Now, in order to collect the gas, what we're going to do is that we're actually going to put the citric acid in these different balloons using this funnel. So what we'll do is we'll set up our funnels here. We'll take our balloon and wrap the edge, wrap the edge around there. Hopefully it doesn't rip. And then we weigh out our citric acid and mix them, put that in here so we can get that in the balloon. Then we'll attach the balloon to the test tube, invert it, get everything mixed, and then wait for everything to be done reacting and see what our results are. What I've done so far is kind of mirror our lab activity where it says put 1 gram of baking soda in our first test tube, 0.5 grams in our second, 1 gram in our third. And so this is 1 gram, half a gram, 1 gram of baking soda. And then I'm going to be adding in this first one here, 0.83 grams of citric acid into these first two. So 0.8 grams in these first two, and then 0.41 grams of citric acid in this one here. All right, I've got all of our masses weighed out here. And so, again, this is 1 gram of baking soda, 0.83 grams of citric, half a gram of baking soda, 0.83 grams of citric. So this has 1 gram, this has the most baking soda and the most citric. This was half a gram of baking soda and 0.83 grams of citric. And then this one has 1 gram of baking soda and 0.41 grams of the citric. All right, so we're gonna go ahead and invert these. And we see they start reacting kind of right away. You can always invert these kind of as well to make sure everything really mixes. Okay, we'll do the same thing for the other ones. Hopefully these balloons don't fly off when you're doing this. One of the reasons we wear our safety glasses in a balloon lab like this. You want to make sure that everything, that we don't have any balloons fly off. Sometimes these spring a leak over time. So we'll kind of watch that and see how they react. One way that we're going to know that they react is going to be that they're done reacting is we're not going to see the bubbles in the test tube. All right. So what we'll do is we'll wait for all of these to react. I might invert them again and that sort of thing. And then we're gonna see if we can figure out which balloon got biggest, which produced the most amount of gas. All right, everybody, so here are our results. There's a little bit of reaction still happening, but not super much. There's, you can see a few bubbles, for instance, in this first flask here. I added the amounts in front of here just so it's easier to keep track of what I have. The NaHCO3, that's our baking soda. And then for citric acid, I didn't write out the formula, but that's what we have. So we had 1 gram of baking soda in these two, the yellow and the clear. And we can definitely see a size difference. The more citric acid we had here produced the most gas. So that the amount of citric acid is definitely important. Comparing these two here, the yellow is definitely quite a bit bigger. Hopefully that's okay to see on the video. So we had half as much baking soda, same amount of citric, and we didn't produce as much gas. And so what we can see that this is a kind of a better ratio of citric acid to baking soda. It produced the most gas. Now, a couple ways that you could test that if your balloons were oddly shaped and things like that, you could use a piece of string and you could wrap it around and you could measure, so you could figure out how far it went around. And then what you could do is you could actually take that measure the circumference, and then figure out the size of your balloon there based on that measurement. If you pinch this off and you could tie it off, you could also maybe figure out the volume by if you tied off that balloon and submerging it in water, maybe in an overflow can, to see how much water was displaced. The volume of water would be the volume of your balloon. But in person here, I can definitely see that the yellow balloon is quite a bit bigger than this pinkish, orangish red one here. All right. What we'll do is we'll follow up with this with some analysis of the calculations. And again, this is the comparing amounts in a recipe lab activity. And what we'll do is explore why did I choose these exact amounts here for this activity. Thanks for watching.